Hey everyone, and welcome to this explainer. Today, we're popping the hood to demystify the infrastructure behind one of the absolute most powerful network operating systems on the planet, Junos OS. If you've ever found yourself wondering how the internet's massive backbone actually survives under such incredible pressure, well, you are definitely in the right place.
I want you to picture this for a second. You've got this massive global network. It's carrying petabytes of sensitive financial data, streaming media, critical communications, the whole shebang. And then suddenly, a single tiny background process encounters an error. In older legacy systems, that tiny error acts like a domino. It ripples outward, crashes the entire router, and suddenly your core network completely collapses. Just total darkness. So what actually keeps the world's highest performance networks from suffering that exact fate? Well, the ultimate solution to that nightmare scenario is the architecture of Junos OS.
So here's our roadmap for today's anatomical tour. We're going to hit the Junos OS advantage, the power of modularity, the brain and the brawn of the operation, and finally, the essential software processes. Let's dive right in.
All right, kicking things off with Section 1, the Junos OS advantage.
You see, Junos OS isn't just some isolated piece of software built for a single device. It's a unified foundation across an entire fleet of routers, switches, and firewalls. It provides, quote, a responsive and trusted environment for accelerating the deployment of services. Unlike a lot of other network operating systems out there that might share a common brand name but are actually splintered into dozens of totally incompatible programs, this is a true single system approach. You learn the tools and the methods once, and you can apply them literally anywhere, which means you can roll out simultaneous updates across your entire product line.
And because of that unified approach, concurrent updates boast a pretty staggering metric, 0. That is the exact number of critical regression errors allowed when a new mainline version of this software is released. No joke. Every single new mainline release includes all the working features from previous versions and is rigorously tested to ensure absolutely no critical regressions slip through the cracks. This kind of discipline is what ensures that incredible reliability for the entire network lifecycle.
Moving on to Section 2, the power of modularity.
So in legacy, monolithic operating systems, all the software processes are essentially tangled together. If a malfunction happens in just one module, say a routing protocol hits a random bug, it can ripple right through the system and cause a full device crash. It's kind of like a house of cards. But the Junos OS modular architecture totally changes the game. Each individual module runs in its own protected memory space. It is completely isolated. So if a process fails, it's contained, it's protected, and it can be independently restarted without taking down the entire router or disrupting your active traffic. It's essentially the ultimate firewall for system stability.
And hey, that magic number 0 pops up again, this time for security. 0 is the number of unauthorized binaries Junos OS will execute without a digitally registered fingerprint. Every single Junos OS image includes a digitally signed manifest of executables. If a binary doesn't perfectly match that registered fingerprint, the system just straight up refuses to run it. This fiercely protects the infrastructure from unauthorized software and potential compromises, so the software is modular and it's incredibly secure.
Let's get into the hardware of it all with Section 3, the brain, also known as the routing engine.
Think of the routing engine, or the RE, as the mastermind. It's this brilliant general-purpose computer sitting right at the top of the system, acting as the control plane. This is where all the heavy cognitive lifting happens. The RE handles all the routing updates from the network, runs complex protocols like BGP and OSPF inside that protected memory environment we were just talking about, and it manages the entire device. Basically, it constructs and maintains your master routing tables.
If you look at the physical makeup, the routing engine is a distinct hardware component that slots into varying chassis series. We're talking the M, MX, and T series routers. But regardless of the massive scale of the chassis it's sitting in, the conceptual role of this brain remains exactly the same.
This brain comes with some serious superpowers. First off, it processes all routing protocol packets. By keeping all of that complex protocol chatter up here in the control plane, it completely prevents any unnecessary delays to the forwarding engine below. Second, it's highly scalable, designed to hold all the routes used in massive modern internet networks. And third, it allows for flexible, really in-depth monitoring, alarm generation, and packet counting, all without dragging down the actual performance of your live network traffic.
But a brain needs muscle, right? That brings us to Section 4, the brawn, or packet forwarding. If the routing engine is the control plane, the packet forwarding engine, or PFE, is your data plane workhorse. Its absolute sole job in life is to handle the actual physical flow of data entering and exiting the interfaces. It applies the filters, it executes the code's policing, and it physically shoots those packets off to their next hop.
Now, how do the brain and the muscle actually talk to each other? Let's walk through this chronological journey. Step 1. The brain, the routing engine, calculates the best active routes and builds a master forwarding table. Step 2. The Junos OS kernel acts as the system's nervous system. It seamlessly copies and synchronizes this master table down to the packet forwarding engine. Step 3. The muscle, the PFE, uses this local copy to physically direct those outbound packets at line rate speed. And because the PFE has its very own copy of the table, the brain can update routes in the background without ever interrupting the active flow of traffic. It's brilliantly efficient.
And here's a really cool technical secret. To achieve maximum throughput, the packet forwarding engine relies entirely on Layer 3 and Layer 4 headers to make its decisions. It never actually contains the packet's core data payload itself. By only processing the addressing and policy headers, the forwarding plane remains incredibly streamlined and just astonishingly fast.
All right, wrapping things up with Section 5, Essential Software Processes.
Remember that modular architecture we explored earlier? Well, here it is in action. The Junos OS kernel coordinates dozens of distinct software processes, which are often called daemons. For example, you've got RPD, the routing protocol daemon. It entirely handles BGP, OSPF, and maintains those routing tables. Meanwhile, completely off in its own world, you have CHASIS-D, solely responsible for detecting physical hardware and triggering alarms. Then there's MGD, acting as the management interface connecting users to the configuration database, and DCD specifically monitoring your physical network links. Because they are totally isolated, if your management interface gets completely overwhelmed by user requests, it doesn't matter. Your routing protocol just keeps ticking away perfectly, saving the network.
So bringing it all together, here is the complete ecosystem. You have the routing engine acting as the brilliant control plane. You have the packet forwarding engine acting as the incredibly fast data plane. You have the kernel sitting right between them as the vital communication link, and you have a small army of isolated software daemons carrying out specialized tasks in protected memory. This strict, uncompromising separation of components is exactly what provides the ultimate operational stability we all depend on in modern networks.
And that brings us to the end of this explainer. But I want to leave you with one final vital question to ask yourself. Based on the modular concepts we've just gone over, is your core network infrastructure resilient enough to survive a single process failure without bringing down the entire system? Because if it isn't, it might just be time to take a page out of the Junos OS playbook. Thank you so much for joining me on this deep dive. I hope you found this breakdown of network architecture as absolutely fascinating as I do. Keep learning, and I'll catch you in the next explainer.